Friends, in the previous video you have seen how to locate the center of rotation for a critical slip circle in a finite slope. So today we will try to summarize the location of critical slip circle for both phi u equal to 0 analysis and C phi analysis. So it's very important to locate the most critical circle. So in a finite slope, as you know that the analysis of finite slope is based on limit equilibrium method. That means when the factor of safety is going to be 1, it is called, and you have a free body, a slip circle that's going to be considered as a free body, and the various forces are going to act over it, and based on limit equilibrium method you have got two methods. So method 1, what you call it, total stress method, or we call it phi u equal to 0 analysis. Or method 2, deals with effective when it is not total stress, but it is going to be effective stress method analysis. Or we call it C phi analysis, C prime phi prime analysis. This is an undrained condition, as you know. Any homogeneous soil mass, and in the undrained condition, when the pore water pressure is not dissipated. So in the after the construction is over, after you have constructed the embankment, the undrained condition prevails, and you require to know undrained shear strength. Cu. Whereas in long term, when the pore water pressure dissipates, or if the soil condition is as such that it is having very high permeability, and therefore it is going to be effective stress method analysis. Method 2, that is C phi analysis. So we have got two analysis. One, it is phi u equal to 0 analysis, and method 2, which is known as C phi analysis. So friends, you know about it. So the determination of the shear strength after the excess pore water pressure has dissipated is mandatory, and that can be easily done. Whereas to simulate this condition, the pore water pressure is going to be, it is a total stress analysis. It is not going to dissipate. And the pore water pressure is a function of what is the vertical pressure. When you carry out the test in the lab, the vertical pressure, you can't simulate the field condition. So you have got long-term analysis, C5 analysis, when the pore water pressure dissipates. Immediately after construction, phi u equal to 0 analysis. And on long-term basis, when the pore water pressure dissipates, this method is going to be valid. But the most important is location of critical slip circle. So what is important is location of critical slip circle. You have got two conditions. One, this. Another condition is this, as explained to you. So location of critical slip circle is a trial and error approach. So it is a trial and error approach. But if you have certain clues, this trial and error can be minimized. Otherwise, number of trial and errors to find out the critical slip circle, which gives you the lowest factor of safety, the minimum factor of safety. And also, it depends upon this location of critical slip circle. What we do it here, three geometric parameters are varied here. So three geometric parameters are varied for locating the critical slip circle. What are those three? One is called center of rotation. Center of rotation. Then what next? You all know that what is important is radius r of critical slip circle. There is another parameters, geometric parameters, that is varied. And the very important is x value, as I have shown in my previous video, that is distance of intercept in front of 2, horizontal distance, horizontal distance, what we call it, also the distance of intercept in front of 2. That is x. So these are the 3 geometric parameters. Those are changed so as to locate the critical slip circle. Now, so many researchers, particularly Fellenius, Jumikis, they have carried out a lot of tests, and certain pattern in slip circle behavior will help you in locating the critical slip circle and minimizing the trial and error. So, very important is what are those certain patterns? That is very important. So, the certain patterns so friends, certain patterns that are very important in slip circle behavior. Which would help you in locating the critical slip circle in a finite slope. So, certain patterns are for phi equal to 0 analysis in homogeneous soil, or phi equal to 0 soil, you can say it, or for phi equal to 0 soil mass. What is the pattern? The pattern is here the value of phi and angle beta, that is the slope angle. This is the angle of shearing resistance. If you find that phi is greater than 3 degree and slope angle beta is greater than 53 degree, it will lead to failure. Very simple. Phi greater than 3 degree and beta is greater than 53 degree. Steep slope, it leads to toe failure. So, this is the first one. The second is for phi equal to 0 analysis, if phi is less than 3 degree and slope angle beta is also less than 53 degree, that means the slope is flatter one, will lead to base failure. These have been observed. So, certain patterns that has been observed by the researchers. So these are certain guidelines which will help us in deciding what kind of critical slip circle will fall. And therefore, for phi u equal to 0 psi, for phi u equal to 0 psi, you know, for case 1, we can easily find it out. What is case 1? This is when phi is greater than 3 degree and beta is greater than 53 degree. That means two failure. That means this is the slope. This is the slope. This is the embankment. Naturally, Fellenius has given you directional angles, and the directional angles are alpha 1 and alpha 2. So, if AB is the slope, what you are going to do? Alpha 1 here and alpha 2 here. This becomes the center of rotation. So this becomes alpha 1. This becomes alpha 2. Very simple. And then you can have this becomes the radius. Very easily is case 1. That means toe failure that's going to take place like this. Exactly to draw it more precisely, right? Then if it is homogeneous, but this is for phi u equal to 0 psi. But if it is C phi psi, that means case 2. C phi psi. And there is the condition. How will you do it? Here, what you are going to get is a failure surface like this. The height of the slope is known to you. H is the height of the slope. So how will you proceed? For the condition, when, how will you find out? How will you locate the slip circle, critical slip circle? So for locating the critical slip circle, what you will have to do it will be as follows. If it is C prime phi prime, then friends, it is going to be this is going to be alpha 1, and here you got it alpha 2. So you are going to get the center of rotation like this. This becomes the radius. Now what I am going to do is go down by h from this point A, B, this is C. So you will have to go down by h and 4.5 times h. This is shown by Jumikis in 1962. Jumikis. Said if it is C prime, phi prime soil. What type of soil? It is not phi u equal to 0, but the soil is pore water pressure dissipates. Now, in this case, you get a point P here. Its coordinate is going to be 4.5 h and h. So, below A, you are going. Now, from P, you join O1. So, you can join O1 and extend it further. So, you are going to extend it. So, just extend it. Now, taking different points over here, you can find out the factor of safety. So, this becomes loci of factor of safety, and the minimum factor of safety is going to be the center of rotation. So, in C prime, phi prime soil, that is after dissipation of the pore water pressure, this method given by Jumikis is going to help you in locating the center of rotation for the critical slip circle. Then you can join OA, taking it as the radius, you can draw the slip circle. So, this is the method, very good method given by Jumikis. So, it was extension of Fellenius work. So, for toe failure, for a steep slope, and then also for phi u equal to 0 soil and C phi soil, the method has been given. Now, case 2 is base failure. What is the condition? Phi prime less than 3 degree and angle beta less than 53 degree, flat. And below the toe, the soil is soft. So, soil below the toe is softer, resulting into base failure. If it is softer, then slope soil above the toe, then it is going to lead to a failure like this. So, friends, the conditions will help you. Now, it is a flatter slope. This is the embankment, finite slope. isn't it? And what you do it? Find out the midpoint of this slope AB. So M is the midpoint of slope and drop a vertical through this. So this is the vertical. What else you are going to do it? Then X, you are going to find it out. As I have already explained in my previous video. And then you are going to have the radius and radius. And this angle is called central angle. Is approximately 133.5 degree. So this is the center of rotation. And therefore, if it is a base failure, the soil is homogeneous, but below the two, it is a softer soil. Then in that case, the central angle is approximately 133.5 degree, and it is going to be on the midpoint. I have already explained to you how you are going to do it. So the guideline is central angle, and the center of rotation is going to lie on the vertical passing through the midpoint. And X, of course, you are able to find out from the chart. If you know the depth factor and the slope angle, you are in a position to find out the value of X. In my previous video, you have seen that, how to make use of the chart, how to find it out. But if there is a firm base, how will you do it? Say this is the now flatter slope. This is the embankment. Here, there is a stiffer layer or rocky mass, rock or stiff layer like this. Then what is the condition? The condition is, here you can find out the value of X and also the slip circle. The critical slip circle is going to be tangent to the stiffer layer. So this slip circle is going to be tangent to the stiff layer. Here also, this is the midpoint, and you know that how to find out, how to locate the slip circle. So certain patterns in locating the slip circle is going to help you by knowing the condition and different conditions. Here there is no stiff layer. So what What is the guideline? Additional guideline is central angle here. Here, what is the guideline? If it is a stiff layer, this circle is going to be tangent to the stiff layer. So friends, in my next video, I will be solving some of the problems on base failure and also on this. So all these things will be discussed by taking few numericals, and I will explain you. I hope these points are crystal clear in your mind, because they are very important. Of course, the computational technique, now because of the advent of computer, the life has become very simple. But if you have to do manually, these guidelines are very important. Thank you very much.